Hello, hello, hello. Happy New Year's. Okay, who's online? Seems to be changing. Let's see what happens if I turn it off. Interesting. I think everybody's still partying from last night, probably with a hangover. Let's see. For some reason, I'm not seeing pe- people's name, participants. Okay. Can y'all write something if y'all online? I see there's supposed to be two people. If y'all can write something, say hi. There you go. Hey, Sal, are you? Hi, how you doing? Where you writing from? I'm always curious. Jose de Jesus Macias Ruiz. Hi, Happy New Year. Hi. Where y'all writing? Jose, where y'all from? Sal, where you from? In case you don't know, I'm in San Antonio, Texas. I'm from Mexico. Hey, Topayo. Hey, comparatia. Man, I screwed that up. I'm from Mexico too. I was born in Nuevo Laredo, Tamaulipas, Mexico. So I'm Mexicano too. So nice to see someone from my country. Are you an engineer, Jose? Hey, Sal. You're from San Diego, California. It's beautiful out there. Expensive, but beautiful. Oh, wow, Jose, you're next to Sal. Sal is close. I think Tijuana is close to San Diego, right? So basically, he's your neighbor. Ah, ingeniero de electrónica. Ah, that's good. Both of you guys are neighbors, and y'all 20 minutes apart. That's good. What kind of qué clase de ingeniero eres electrónico? ¿Qué haces? ¿Haces software or hardware? Power electronics, más o menos. I'm always interested in seeing what you guys do. How about you, Sal? De productos. Ok. Hay muchas maquiladoras en Tijuana. Oh, okay. Emergency LED drivers. Okay, that's good. So you're a power engineer. That's good. So you all use the PWMs and so forth. Okay, and Sal, I hope I can pronounce it. It's Ayub. How you doing, Sal? You're power electronics too. So both of you guys are in power electronics in the San Diego area. Man, that's good. So I asked Jose if there's a lot of maquiladoras, which are factories in TJ, pero la mayoría son industrial médica. Oh, wow. Okay. Esos tienen también ¿cómo diré? Especialidades. No, no, no es muy común, es mucho más difícil porque es industrial médica. Yeah, that's at a different. Oh, wow. That's good to know, Jose. That's wonderful. So Jose is in TJ in Mexico. He's a fellow countryman. He's a power electronic engineer, and he works with different topologies and some of the medical products that he works. And Sal, who do you work for, Sal? Sal said that he is a power engineer as well. Of course, yeah, I'd like to know where you guys work if possible. I mean, I don't want to get you in trouble if you can't tell me, but it's always nice to know. I work, for me, I work at Southwest Research Institute. I do space power supplies. Uh, Basically, in space power, we keep it simple. Basically, flybacks, typically 20 watts and below. We do some resonant flybacks for very, very low but high voltage power supplies. And then we also do for higher power. The most power I've done is 200 watts. Uh, it's not no kilowatt range. It's just much lower power. And the reason is because it's in space. Space, there's not a lot of power available. So those are the two main topologies that we do at work. So, oh, hey, Sal, are you JPL NASA? Cool. So, do they have? Okay, so Sal. Oh, Sal, are you the guy that was interested in? Are you the same Sal that sent me an email about worst case analysis about the book? Ah, Okay, so I know you. We Skyped. Yes. That was a nice chat. Yes. I got your email. I've just been real busy with the Christmas and was on vacation, but I had a lot of honey do this. You know how it is. Honey do that and come spend time with the family. So you know how it is, Sal. Yes, I'll see if I can get you the document. I gotta find out because, like, excuse me, I showed you the books. It's two huge binders, and I know you try to get it. I guess my question is, I thought you found, I thought you found a source for the worst case analysis book. Uh, did you ever get it from them, or it didn't work, or I'm just curious. Oh yes, but not the same. Okay, yeah. Sal here. He approached me about. I probably will do some videos on worst case analysis. Uh, it would help him and other engineers that, and I guess I'll show the way I do it, or at least the way I've been taught, or I've been doing it the last few years. How to I do it. I'm pretty sure other engineers would do it a little bit different, but I typically use Spice, and the Spice simulator that I use is Top Spice. That's my preferred simulator. But for worst case analysis, I found that MicroCap has a real neat uh, worst case analysis feature. It's really, really neat. So that actually simplifies a lot of stuff. The most of the work is done up front. In other words, you have to do your database, and that's what takes a lot of time. You have to get your data sheets, and then do your temperature and your environmental, and then try to calculate your worst case analysis off of that. Okay, well that's good. I'll get back with you on that. Said don't let us off it. This is really good software. Yes, it is. It's a really good software. Really, really good. Okay, so let me see. Oh, Jose said he works at Signify. So it was previously Philips Lighting. Oh, okay. So I now I see what you do. So it was lighting. So it was used. I'm assuming that it used to be light bulbs, but now they're light LEDs, which are the ones that I have here. See, I can turn them on, off. So these are LEDs. So I see. So your design LED. So they're not voltage control. They're more like current control. Is that right, Jose? You're controlling the current. Okay. Ah, so it's the LED drivers. Yes. Okay, so you do the drivers. Okay. So when you say a driver, is it like a PWM that or is it the whole system? Yeah. Yeah. So on the LEDs, are you able to adjust the current? In other words, to brighten them, you increase the current to make them light up, and vice versa, and turn it down, right? Yeah. Well, you would have to. You can't use the voltage. since LEDs have different, depending on the what LEDs they have different, yeah, reducing the current. So you probably reduce the current by changing the duty cycle on that. So just based on the amount of LEDs configuration. Yeah, yeah. I'm assuming that you can connect them in series, and maybe parallel configuration. I guess you can do a bunch of them. So like the ones that I have here, I think they're. I'm using some under my bench here, and I would assume they're connected in series, and they have a little driver or a little power supply. So that is good. I'm glad. So I guess uh, I used to work in the semiconductor industry, which is totally different from what I work in. I used to work in a fab. We actually made the chips, and in the industry, and before that, I used to work at RCA, General Electric, and Motorola. And I guess my question is, eh, uh, when I was in the industry, as opposed to uh, some of the NASA work that I'm doing at Selfish Research, we had cycles where there's a lot of work, and then there's not too much work, and so it comes in cycles up and down. So is right now like the LED industry? Is it fairly constant or is it cyclical? So this is a question for Jose, and I'm just very curious if in the industry how much of a fluctuation there is in that type of work. Oh, that was a question for Jose. I don't know whether he's still on or not. Okay, very constant. Oh, okay. I'm sorry. He did answer. Yeah, I forgot to scroll up. Sorry. Senior moment. He said right now it's very constant the amount of projects to develop. Okay, good. That's good. Yeah, with the economy, that's been my I guess my concern is being that the economy is with inflation and so forth. Sometimes companies have a habit of cost cutting, cost saving, and they sometimes they slow things up. So I'm just wanting to see get a temperature of what industry is doing out there. Well, guys, do you have any question for me? I know Sal. I know his question. He wants me to uh, uh, do that. A copy of a worst case analysis handbook that I have is no longer in print, and the publisher is no longer available. So, but it's a real big book, and there's probably like 600 pages that would have to be scanned. So, I know he wants that. I'll let me find out because it's I couldn't do it here. It would take me forever. So it would have to be like Office Max or one of those companies. But I'll try that. I'll I'll try. But how about you? Say any questions or even use out other than the worst case analysis or anybody else that may be on? Ah, okay, okay. So now, Sal, the pressure's on me now. See, there's another person that is interested in the book that you're interested. Okay, so I may have to maybe do some kind of a. Yeah. Uh, yeah, it's root. y- Yes, I can see the need. When we do when I try to do the worst case analysis, if we have enough time, we do them there at Southwest Research, and but if we don't have enough time, we use AE, Analytical Engineering, and Charles Himowitz is the one in charge there, and they do a really good job in uh, doing the analysis. And one of his engineers that I work with, his name is Paul Ho. He's really good. So if your company or your project is important enough and you need support, and they're expensive. Well, I don't want to say that they're expensive, but analysis by uh, worst case analysis is very time consuming, and it's expensive. But they already have a database already, especially for space. They have a database already at their disposal that they've made, and they use that, uh, and they customize it to your mission period and so forth. So uh, if you can't do it yourself, then they would be the ones. So it's kind of like a plug for them for right now. Uh, but they're really good. But in the meantime, I'm going to see if I can, as I start the year, I'm going to see if I can do a video on worst case analysis. It looks like there's an interest of that. I did do one little video. It was like an internal video for some of the staff engineers, or not staff engineers, uh, or junior engineers at Southwest Research. But it was very superficial. So I'll see if I can do something where you guys can get a gist of how to do it. Okay. Any other questions that you guys may have for me, or interests? Oh, let's see. Here's something interesting. I'll probably do another video uh, on the Bodhi 100. Do y'all use the Bodhi 100, Sal? And how about you, Jose? Do y'all do the Bodhi 100? Oh, a tour on my bookshelf. I got a bunch of books back there. uh, and I have another part of the library that's on the other side, so I have some other books. Uh, I haven't had time to do some housekeeping, and but the books that I recommend, or the first book that I on power electronics that I picked up, was the Pressman book, Abraham Pressman. That's the one that that's the book that actually got me into Southwest Research. Believe it or not, at yeah, uh, basically I read the book, and at the time I was taking some VLSI design classes, and I did like a bulk power supply, and I used the K factors that are in the book, and I was able to compensate it. And when I went for the job interview at Southwest Research, I had done a lot of the simulation. I had the nice plots and so forth, and the compensation, and they had never seen uh, uh, a candidate to bring in some simulations, and that book really got me in at Southwest Research. It's real hard to get into Southwest Research, extremely hard, but that book basically got me in. The other book that I recommend is the I recommend all the books from the late Sanyaga Manitakwa. Those books are very readable. I really like. Uh, his writing style, and they're just very readable. And uh, it has just enough math for. I mean, there's textbooks like the fundamental electronics by the from the folks at Colorado, University of Colorado, um, Erickson. That's a good book, but it has a lot of math and it's very math intensive. And so I tend to go more for the Pressman type, the Sanyaya type of books. So those are the books that I really like. And then the other book, of course, is from Christopher Basso. You guys are, I'm sure you are familiar with the Christopher Basso. I have the first book that he came out, and then the second edition. The second edition has more meat. It's a much thicker book, and and those are basically the books that I use. There may be some other ones that I forget right now. I did buy the the latest book. Let me see. Okay, this is a huge book. Okay, so this is the Christopher Basso book, and it's the transfer function of switching converters. So I just got it about a month ago, and it's hefty. And you would assume that the writing would be like big fonts, but actually, see if you can see, they're kind of small. In other words, it's got a lot of information. So it's kind of like a Bible. So this is a really good book. So Christopher did a real good job on that. So I got that. Now I did ask. Thank you. You have these two books. Okay. Okay. Tuang Pham. Okay. He says he has two books. Yeah, the two books. And then oh, thank you for sharing that. I always like it when people tell me about themselves. I'm always interested. He says that he's a young electrical engineer, half seasoned on power supply, half on generic electronics, and I am a hobby electronics guy too. Oh, that's good. That's good. Yeah, when electronics is your hobby and you get paid for it at work, it sometimes it doesn't seem like work. Or I mean, I love what I do at work. The only time where I don't like it is when there's deadlines, like this has to be done by sunset, and then the pressure is on you. So that's the only down. But you there's pressure everywhere you work. I had asked what kind of uh, FRA analyzer, and Jose de Jesus Macias Ruiz, they use the Venable network for their body plots. At Southwest, I have access to all three of the major ones. I have access to the Venable, the Ridley, the 310, and we have two of the Bodhi 100s. And I have let me see if I can turn this. Okay. I have a computer here, so I That's my Bodhi 100. So that's what I use for my home lab. So if you've seen videos that I posted, those videos are done here in in my home lab. I don't do them at work because they frown on that. They want to keep things, uh, how can I say, uh, controlled, I guess. Then so I do any of the body stuff. I do it here in my home lab. Uh, Now, one of the things that I have done recently, I posted some videos on, and and this is in response to Sal. Sal says that he uses PSpice for the body plots. So when you use PSpice for body plots, are you talking about FRA analysis or loop response? Is that what you did use PSpice for? That's a question for Sal. Okay. So recently I have posted two videos on Top Spice. Top Spice is developed by Pinsar Development, and uh, I guess a year and a half, I approached them after seeing a video posted by Dr. Ridley. Dr. Ridley has a software. Uh, I think it's called Ridley Works, and on Ridley Works, I think you can push, you can design your converter, and then I think it exports a LT Spice model, and you can do FRA response using transient analysis. And I thought that was kind of neat that that you can do that. So I approached Top Spice or Pensar Development, and they did implement a FRA feature on it. And they put a little menu where you can fill in, and it's very similar like what you would do using a Venable or a Ridley. You have your start frequency and a um, and a stop frequency and so forth. So LT Spice can do that. So I approached Pensar to see if they could do that, and they did. And the only thing was that LT Spice at the time, about a year ago, or until recently, was faster than Top Spice. So about maybe 6 months ago, I approached Top Spice or Pensar to change the algorithm, and I gave them some suggestions, and the suggestions that I suggested actually sped up Top Spice. So now Top Spice is faster than LT Spice in terms of a FRA, or at least that's what I've tested so far. Uh, uh, so if you look at my YouTube channel, there's two videos, and I show the difference in the speed. So I think that's something really good. I know that a lot of people are using LT Spice because it's free, and it is a very good simulator. But from my personal experience, I've found Top Spice to be uh, a little bit more accurate. And the reason that I'm saying that is I did a simulation of a Royer. It was a Royer power supply, and it's a Royer is basically a transformer uh, feedback oscillator, and typically on the bottom you have a current source, and whenever you have that type of topology where you're feeding your driver with a current source, uh, there's a capacitor at the current source that if that capacitor is too big, it messes up the time constant, and you get what is called squedging. Squedging is a condition where the current source it it biases correctly, but then there's too much capacitor, and then it basically the current source turns off. So then it turns off, and then the oscillator starts again. So you got this off, off, and that's called squedging. Another name of it is called motor boating. So anyway, so I did a simulation and I simulated it on LT Spice, and I could not see the this squedging effect. So then I went and did it on Top Spice, and I saw the squedging. So that's why I'm saying that from my experience, and by no means am I a LT Spice expert, but but I kept everything basically match, and I was able to see that phenomenon that we were seeing on the bench of the squedging. So I'm able to see it using Top Spice, but with LT Spice I could not get it to to show that effect. So anyway, I know there's a lot of people that like LT Spice, but if you have a chance to try Top Spice, I highly recommend it. And then the other one, free one, is of course Microcap 12, which is really good. So that's a nice, very powerful simulator. So all of these simulators are really good. So you really can't do a lot of real good engineering work without having a very good simulator. So I'm glad that at least there's two of them that are free: LT Spice and Microcap. And and Microcap or Top Spice is affordable. It's $600, which is affordable to most engineers. So anyway, so let me see what else. So anyway, those are the things that Top Spice just came out with version 10, and they made some really good improvements, and the simulations that I get there matches my what I get on my Bodhi 100. So they're really good. Okay. Uh, Tuang Pham says that he had the chance to meet Mike. Ah, that's why you're. He says that he's a fanboy of LT Spice. Nothing wrong with that. It's a good simulator. And Mike Engelberg, or I forgot. I think it's Engelberg. Is his name. There is a video online where he talks about LT Spice, and he knows how to use it very well since he wrote it, and it's a really good simulator. But I'm, I'm more familiar with Top Spice. Okay. See. Y'all have any other questions that you career or electronics? Oh, Sal says Top Spice. Yes, Top Spice has a free download, so you can download just like Top Spice. It's parts limited or circuit limited, but if you download it, you can get a feel for how it works. The other thing that I do like about Top Spice and Microcap is, and the big advantage that I see over LT Spice is that both Top Spice and Microcap, they have a huge library. Well, I think both of them have over 30,000 models. So between both of them, the uh, you basically have quite a bit of models to select. Yeah, I do have. I think I have over 100 videos on my YouTube channel. So I believe I have about 38 on flyback. So I start from the beginning and try to show practical uh, videos, I guess you could say, or at least a lot of the videos I make them when I find something at work, something that I learned, and 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 I think to myself, oh, this is kind of neat. This would be nice information to share. So I've done a lot of those videos on flyback and also on design and so forth, uh, and how to simulate. So I think there's quite a bit of videos that I've done. So up, but like Sal said, I'll probably do a video on worst case analysis. That's something that probably is needed out there. Oh, I think here's a question. Any of you guys planning on going to Apex? I think it's in Orlando. Apex. I'm planning. I'm gonna ask my boss to see if they'll let me go to Apex. Yeah, last year it was in Houston, so I was able to attend that one. Hi, Arthur. Happy New Year's. Where are you writing from? Where are you at? It's always fun too. And Twelve Fam, where are you writing from as well? I'm always interested in finding out where people are, where they at. Oh, okay. Brazil. Ah, Brazil. Ah, bienvenido. Welcome. Power engineer. That's cool. Oh, so you're in the United States. We're in the US. Thank you, Arthur. Appreciate your comment. You're in Virginia. Ah, cool. So you're 1 hour ahead of me, I think. I'm in San Antonio, Texas. That's cool. Have you been practicing engineering for a long time or? Oh, yeah. Then you've been practicing for some time. You're seasoned. Oh, that's good. That's good. So, Virginia, where did you go to school? Did you go to school in Brazil or here in the U.S.? Oh, yeah. The U.S. is a great place to be. Yeah, I was lucky enough. I was born in Mexico, so I was lucky enough that my parents immigrated uh, when I was young. I was, I believe, 3 years old when my parents immigrated. So yeah, I'm lucky to be here. So yeah, the U.S. is the land of opportunity. So Yeah, I'm not familiar with ECCE. I'm gonna have to look up, but I am planning to go to APEC. I believe my boss said that I could, but I just want to be sure. It's in 3 months, and before you know it, 3 months is here, and so I gotta get my stuff uh, ready, my travel arrangements. First, I gotta ask permission to see if they'll let me go. ECCE is in Nashville. Now, can you type out what the acronym ECCE? I'm not familiar with it. And when is this conference in Nashville? Oh, okay. Energy Conversion Congress. Okay, cool. Typically, they let me go to one. I'm not sure if they'll let me go to two. And the one that I really want like to go is the APEC. Maybe not as big as APEC. Yeah, an APEC I like because there's a lot of classes and seminars. So, hey, and I believe it's in Florida. It's supposed to be really nice. So, I told my adult kids that I might be going to Florida to attend APEC. They asked me where, and I said Florida, and they're like, "Can we go?" So I may have my adult kids come with me. Yeah, they wanna. They say, "Yeah, Dad, you can go to the conference, and we'll stay in the hotel, and then go to the sightseeing." So they want to tag along. My wife might not. My wife is a teacher. She can't take days off, so I might not be able to take her. But that would be neat. Well, hopefully, if you guys go to Apex, if maybe we can meet there. I think it'd be kind of neat. It's always nice to meet other people. One of the things that I really like at APEC are the displays and talking to the vendors. That is always nice. Uh, Seeing, the new products that are coming out. The last few years, there was a lot of emphasis on GAN FITs. There was EPC there. Um, GAN Systems was there, and other vendors, and then I believe some of the other vendors are like, really had his booth there, not in Houston, but when in San Antonio. That was in, I think, in 2018 or 17. So it's always nice to meet with the vendors and interact with them there. So that's neat, and also meeting other engineers and sharing experiences. Well, that's good. Let's see. So, Arthur, so what kind of? I know you work in power electronics. Is there any particular products that you all work on there in Virginia? And what kind of topologies do y'all work on? And the reason I ask is because I'm limited to power systems in for space. So in space, basically we do flybacks, resonant flybacks, and two switch forward. Those are We don't do anything like half bridges or stuff like that. Those are high power. So I'm always interested what other people do. Okay, so you do DC to AC. So you do inverters. Okay, okay. Yeah, we did have high voltage. How how high of a voltage are you working with? Whoa, 20 kV. Wow. Now this 20 kV, is that high current or low current? I would assume it would be low current. That's a lot of current. I mean voltage. I think the highest that we've done. Yeah. Okay. Yeah. The in space we use a high voltage power supply for the mass spectrometers, and typically anywhere from 2,000 all the way to about 15,000. That's our kind of the range, and we use a small, and this is all low current because we're driving basically plates in a mass spectrometers and grids. So they're basically the load is capacitance. So our currents are very, very low. So even though it's high voltage, we're talking about maybe 100 microamps. So, and everything has to be very, very well insulated. So, okay, here's like a little project. This is supposed to be this is a little bit different, although the high, this is supposed to be a RF oscillator, and if you notice, this is the way a breadboard stuff. You can do you can use a diamond tip, and you can make little circles. Like for example, there's a little circle there, right there, and basically you do an island. The other thing that you can that I when I'm breadboarding, oh, these are little knee pads. There's a company. I believe it's a radio uh, ham radio guy, and he sells these, and you can break these. I think I showed this. So here's so you can, let's say you can break these, and then you glue these onto your board, and or you can use, like I said, diamond tip, and I believe this is called a Manhattan type of prototyping. So here's a RF coil, and this thing is supposed to oscillate like at 2 megahertz. So we're trying to get that shrunk, made more smaller, uh, make it space worthy. So, and the RF is supposed to be like 1600 volts sine wave. So those are the things that we do. So, okay, yeah. So you use this to lower the field intensity. Oh yes, uh, the guy I have a design partner. His name is Charlie Nunez. He's originally from El Paso, Texas, and he's a young engineer. Well, I met him when he was 26 years old. So, and we've been together almost 19 years. So he's my design partner. So he is the high voltage expert there at Southwest Research. He's just a phenomenal engineer. And we do have two layout guys, and they're really, really good in designing the layout and making sure that we have the proper spacing for high voltage. So that's another thing that helps us. So within, with our Charlie Nunez and then our two design layout guys, we're able to produce some really really nice high voltage power supplies, and also some high voltage steppers. So yeah, there's an art on that. Okay, Fam asks, anyone working in automobile electronic like traction inverters for EV, DC, and DC? Okay, take care, Arturo. Art, nice meeting you. He's got to go work tomorrow or the following day. Okay, take care. See you, and I wish you a wonderful and a prosperous new year. Take care. Uh, at Southwest Research, we do have a automotive division, and I believe they have. Well, first of all, we do have a automotive division at Southwest, and they've had that division since it opened up. And basically, they do research on lubrication, oil, and they also do other vehicle stuff. And I believe they have either a facility where they do battery testing. So they do that. We don't get involved with them because it's automotive, and our division is strictly space. But at Southwest, we do have automotive, and we do have another division. It's called Applied Power. They work with the grid. So there's several divisions within Southwest Research that address different types of power applications. Division 15, which is the one that I work with, is strictly space. Now, we do have a new division, Division 5. Uh, Originally, those folks at Division 5 were with Division 15. They kind of broke off, and now they're a division of their own. And the director or the VP of that is Mike McClendon, and his folks there. And I believe they're going to be. They took over a new building. They actually Southwest Research built a new building uh, so they can build spacecraft. Before the new building was built, uh, the stuff that we did was basically just the instrument, and then we would send them to JPL or Ball Aerospace, and they would assemble our instrument into the spacecraft or the payload. But now we're we want to get, or Southwest wants to get into business of building the whole spacecraft. So they built a brand new building, brand new, with a high bay, clean rooms. I mean, state of the art, and so now we're gonna go after the small and I guess mid-range power systems. So I think that's that's something that is going to take off. Probably will be with Southwest 2 more years. So I'm not sure if how much of a growth they'll have within that time, but The people that are there in Division 15, they're really, really good. They've been doing it for a long time, so I'm pretty sure that they will see phenomenal growth. As it is, uh, Division 15 split into Division 5. That's all big growth. So uh, there's a lot of work at Southwest Research. Anyway, it's getting it's about an hour. I guess I'm gonna call it quits here. Thank you for watching, guys, and Sal. I don't know if you're still on, but I will try to get a copy or see if I can do an electronic copy of the worst case analysis. And I believe there was Jose that was interested, and I probably will do some videos on worst case analysis. If there's topics that you guys are interested of me covering, go ahead and if you can email me or post them here, I'll take a look and see if it's something that I can do. If it's within my expertise areas, I'll certainly entertain doing something like that. Just remember that these videos do take time for me to film, edit, and so forth, and it's quite an undertaking. So, if you see a 15-minute video or a 20-minute video, I, I, I typically will spend 3-4 hours, trying to simulate and get things done. So it's not, uh, for me, it takes me time to do. So anyway, hey guys, I wish you a happy New Year's. Thank you for stopping by and chatting. It's always fun for me to see where people are from, what they do. I get emails from all over the world, and it's fun for me to hear what you guys are doing, so forth. So keep in touch, and probably next month I'll do another streaming video. Thank you for watching, guys. You all take care. Bye.